Hello, welcome to Unit 8. This is Miss Moreland. We're going to start with 8.1, Factors and Greatest Common Factor. So first, you should be familiar with these from day 1. Remember, we're going to multiply these two together to get the top part, and then add these two to get the bottom. So we're looking for a number that added to -6 gives me -9, and that number is -3. Nope, hold on. Clearly my computer's thinking. Oops, -3, not equals 3. And then I'm going to multiply them and get 18 up top. So take a second and fill out the rest of these. Pause the video. Oh, stop thinking, computer. Alright, so we're looking for two numbers that multiply to 21 and add to 10. And those would be 7 and 3. And this one I'm looking for when I add a number together, I get 10, that'd be 3. So really I just get the same diamond as the one next to it. And now you're going to have some definitions. You should know what a prime number is. It's a number only divisible by 1 in itself. So we have 2 is our first prime number, then 3. And 2 is a funny one because it's the only even number that's prime. 3, and then we have 5, 7, 11, 13, and we could go on for a while, but those are some examples of prime numbers. And then a composite number is the exact opposite of a prime number. It's a number that has factors other than 1 in itself. So 4, for example, has factors 4 times 1 and 2 times 2. So it has factors right here like 2. Right? A couple more definitions. Factors are what we just talked about. They're the numbers that are multiplied to get the product of. Okay? So for example, like I just wrote, 4's factors are 4 and 1 and 2 and 2. You can use the factors to write a number as a product. So we have something called factorizations. So the factors of 16 are 1, 16, 2, 8, and 4 and 4. And we're just going to write 4 once. Factorizations would be similar to that. It's just 1 times 16, 2 times 8, and 4 times 4. Factorizations just means you write what's actually multiplied together to get the number. Okay, and the next and final piece we're going to have is prime factorizations, which means when you write all the factors down, they all have to be prime. And you guys should have seen factor trees before, but that's what we're going to do for prime factorization. So our first example here is 60. So what I like to do is just start with two numbers that I know multiply to 60. So 6 times 10 is 60. And then I keep breaking it down until I get to prime numbers. 6 can still be broken down into 2 times 3. But as you saw before, 2 is the only even prime number, and 3 is also prime. So I'm going to circle them when I get down to the end. Now I'm going to break 10 up. 10 is the same as 2 times 5, and those are also both prime. So if I'm going to write the prime factorization, I'm going to write 2 to the second, because there's 2 2's, times 3 times 5. That's the prime factorization of 60. If I multiply those together, I will get a product of 60. Right, the next thing we're going to look at is greatest common factor, which you've probably seen this as well before, but the greatest common factor is just the largest factor the two numbers have in common. So what I like to do, this is the method I use. There's other methods if you look in your book, but I just write the factors out. So I have 1 and 12, 2 and 6, and I go in order. I go 1, then 2, and then 3 and 4, and then I'm back to 4, and then I don't have any more. 32, I do 1 and 32. Then I move to see if it's divisible by 2, and yes, it's 2 and 16. And I think, is 32 divided by 3? And if I wanted to, I could check on my calculator. But it's not, so then I move on to 4 and 8. Not divisible by 5, not divisible by 6, 7, and I'm back up to 8, so I've got all the factors. So then I like to circle the factors they have in common. They all have 1, so I don't circle that. The computer keeps thinking. It's lovely today. So they have a 2 in common. They have a 4 in common. And that's it. So the greatest common factor is 4. Right, so I want you to pause the video on this next one and try it on your own of 25 and 60. So write 25 factors and write the factors of 60 and see which one is the largest. So I have 1 and 25 and 5 and 5. 25 is easy. I'm going to bet that it's 5 just because it's only one of 25 really, but I have 1 and 60, 2 and 30, 3 and 20. You'll have to check this one. It's 4 and 15. 5 and, let's see, 12, 6 and 10. Okay, and I could have stopped way back here and once I saw 5 because that's the only other number that 25 has, so the greatest common factor is 5. Now we're going to throw greatest common factor of monomials, and you should remember that a monomial is just one term. It's got numbers and letters though. So here's your steps really. Find the greatest common factor of the numbers like we've been doing, and then find the greatest common factor of the variables. The variables are really easy. You just pick the smaller exponent. So this one's an x to the third. This one's an x squared. If you think about it, x to the third is x times x times x. X squared is just x times x, so they have two x's in common. So I know that when I do my GCF, I'm going to have an x squared because that's all they have in common. The third is extra. Now 15 has 1 and 15 and 5 and 3. And 9 has 3 and 3 and 1 and 9. So the biggest factor they have is 3, so the GCF is 3x squared. Alright, pause the video on this next one and see if you can find the greatest common factor of 8x squared y and 25y cubed. Without having to write the factors out, I hope that you can see that 24 is divisible by 8, so the greatest common number in is 8. Then I look and I see that this one has an x squared and this one doesn't have any x's, so they don't have any x's in common. This one has a y to the first and this one has a y to the third. Remember, you pick the smaller exponent, so it's just y to the first that they have in common, because this one only has one y and this one has 3. All they have in common is one of them though. And again, this is what I've been saying the whole time for the variables. Helpful hint, what have you noticed about the variables? The two terms contain the same variable raised to different powers. The GCF will be this variable raised to the lower power. So you just have to pick the lower power for that. Alright, that's the end of video number 1. Try the on your owns tonight for homework. Oops. And have a good night.